Hi, in this screencast, we're going to demonstrate how RepreZen API Studio can be used to build APIs in a contract-first approach. We'll start with a Swagger model that describes an API and use code generation to create a server stub using Java Jersey framework. Once the stub has been generated, we'll provide implementations for the methods, and then we'll demonstrate all the API methods by making requests to the running server with curl. Next, we'll edit the model by introducing a new method that doesn't yet have an implementation. When we regenerate the server, we'll see the compilation errors in our implementation class, which we'll fix by implementing the new method. Then we'll go ahead and test out the new method. So here I'm starting with a new installation of RepreZen API Studio in a new empty workspace. First thing I'll do is open up the project view, which I prefer to have open, and then I'll create a new model project using one of the examples in the example wizard. Okay, we've got our model. Let's take a quick look at what's in it using the quick outline view, which I invoke with Control O. We've got a total of 4 methods on 2 paths, and we're working with 2 different data types, not counting error, which we'll ignore in this screencast. In project view, let's see what generation templates we got automatically when we created the project. It turns out the one we want is one of the factory defaults, Java Jersey JAX-RS server. So we'll dive into that folder and open the gen file that contains parameters for the generation. The only one we'll change here is the output folder for the generation. Normally it would default to a folder named generated that sits inside this gen target folder. But I'd rather call it implementation and put it right next to my models folder. So I'll change the folder path, which is relative to the gen target folder, to one that will put it where I want it. Now I'll run the code generator to get a stub for my server implementation. All went well, and I don't need to be told when that happens, so I'll uncheck the box and close the dialog. Now I want to work with that generated code as its own Java project, so I'll right-click on the folder and choose Import. I'll be importing an existing Maven project since that's what this generator produces. Once that finishes, I've got a brand new Maven Java project, which is bound to the implementation folder that I created in the model project. Let's take a quick look around and see how the generated code is organized. Of course, this all depends on the generator itself. It's not something that API Studio controls in any way. This looks like the right class for our method implementation, so let's edit that file. Okay, we've got some color problems since the default color schemes set up by API Studio don't work very nicely with the Java editor. No worries, we'll change the color theme and preferences to the minimal theme. Not very exciting, but at least we can read our code. Let me get rid of the RepreZen dashboard and prevent it from popping up anymore. We still have problems due to the edit box shading. Rather than fixing those settings too, we'll just do without edit box. Oh no, I need my Emacs editing key bindings. So we'll go into preferences and fix that. Much better. We're going to be editing Java code, so let's open the Java perspective to make that easier. I'll close a couple of panels on the right so we have a wider editing panel. We don't need to keep the gen file open, and I'd like to keep the Swagger model in view as I work, so I'll drag that tab over for a split screen. Now let's get to work. Here we see stubs for all the methods defined in our API. Before we start implementing them, let's create a fake database of pets. This will just be a map of IDs to pets. And since we'll be allocating IDs, we'll create a field for that too. Now let's get to work on the first method, addPet. I can click into the model editor and use Control O to open the outline quick view. Then I can search by typing addPet and click on the method to immediately jump to it in the editor. We see that we'll be taking a new pet structure as a body parameter and return a pet structure. The new pet is for pets that are not yet in the database, so it lacks an ID property. Pet adds that property, so it represents pets that are in the database. So this method is fairly straightforward. We'll create a new pet object, fill in its ID using the next available ID value, and then copy other fields from the incoming new pet. Oops, I'm filling in a pet when I should be filling in a pet to add. Okay, better. Now we need to add it to the database. And we'll return a 200 response with the new pet object as the response payload. Looks good. Now we'll move on to the next method, delete pet. Here we'll be taking a pet ID and returning a 204 response without a payload. We'll check to make sure that the ID exists in the database, delete the entry, and then make our 204 no content response. If the pet doesn't exist, we'll return 404 not found. We can see from the method signature that we could throw a not found exception, but that only permits us to send back a string in the response body with the text plain content type. We want our implementation to always return JSON, so instead we craft our own response with a JSON text node that will ensure that the string is rendered properly as a JSON string in the response. Okay, on to the next method, find by ID. We're given an ID value as a parameter, and we'll want to return the corresponding pet. Again, we'll only do this if the pet exists. Otherwise, we'll want to do this not found response as before. Instead of repeating the code, we'll use code refactoring to turn our prior code into a method and then reuse it. One last method, findPets, which has two parameters, a list of tags and a numeric limit. We'll want to return a list of pets with the provided tags, but no more than the specified number. So let's create a list of results and then add all of our pets to that list. Now we'll implement our tags check, but only if it's actually supplied. Finally, we'll exit the loop early once we've reached our limit, assuming one was given. Last but not least, we'll make our response with a list of matching pets as the payload. Cool, we're all done with the code. Now let's see if we can run it. We see in the README file that we should run this using Maven with clean, package, and Jetty run as the goals. We don't really need to clean each time, but we can invoke Maven by using the run as entry in the project context menu. We choose the Maven build ... option, which allows us to fill in goals. We do that and push run and oops, it didn't work. Let's see. Oh, we're using a JRE by default instead of a JDK, and we need the JDK in order to compile, among other things. So back into preferences, and this time we'll adjust the Java install JRE settings. Sure enough, API Studio only knows about a JRE, so we'll tell it about our installed JDK and make that the default. Now let's try again. Great, it appears that Jetty's listening. Now we'll switch to a Cygwin bash shell, where we can use curl to test our implementation. I've written a little script for this, which you can pause and scrutinize if you want. But now let's just run it and see what happens. The script shows an API request ready to send, and then waits for us to hit enter. Then it shows the response it receives from the server, and again waits for enter. This first request just shows that the database starts out empty. Next, we'll add a few pets, Snoopy, Garfield, and Remy. Yep, they're all there. Now let's try the query parameters on our fancy find method. We'll find only dogs and rats. Great. Next, we'll delete Garfield. No more Garfield. We'll look up Snoopy using his ID of 0. And then look up Garfield and get our not found exception. Very cool. All our methods seem to be working, but we have a problem. Snoopy's name is misspelled, and we don't have a method that would let us fix that. So let's go add a put method that lets us replace an existing pet in the database. We won't go through all the details of these changes, but first, here's what our new method looks like in our model file. With that model saved, we switch back to RepreZen perspective and then run code generation again. Now that the model's all set, we'll switch back to Java perspective and take a look at our implementation project. The red markers show us that something's wrong. We need to implement a new method that's been added to our interface. Here's our new method. We turned some of our addPet code into a new method, makePet, and reused it here. Now let's restart our server. Oops, didn't run. Oh, it's because we never quit out of our former running instance. We'll take care of that and then try again. Much better. Okay, back to Bash. We'll prime the database by running all the prior requests in fast mode. Now for the new requests. First, we use our new put method to fix Snoopy's name, then get a final list of the pets to see that everything's correct. That pretty much does it. Thanks for watching.